Okay, this video is to serve as an introduction to Chapter 1 and basically to statistics in general, and then to look over Section 1.1, which is describing categorical data. So there's really some key definitions that you need to understand. And before I get into them, let me just say, understanding the concepts of statistics is really the best way to do it, is to be able to pick them out of a context. It's not so much memorizing definitions, which is not the worst idea in the world actually, but the main sort of skill that you need to be able to develop in regards to terminology is to be able to pick them out of a context and to be able to explain them in a context. And that's really the best way to understand them, and that's really what I'm going to try to do throughout the years. It's always going to be some context that we are working in, and that we're going to try to understand our terminology through. And so the first couple of things is the concept of individuals. Now, statistics basically is the study of data, and data is information that describes individuals. So individuals are just the people, animals, or things that are described in our set of data. Our population is the group of individuals we want to know something about. So we're always talking about what is our population, what is our group of people, animals, or things we want to know something about. So the population could be, let's say, every voting age person in the United States. And the parameter, which we'll define later in the year, would be, let's say, the percent they're going to vote for a candidate. Or the population could be every tree in a particular forest. All right, so the individuals in essence would be each tree. The population, could be, let's say, every tire in a warehouse full of tires, and so the individuals are in essence each tire. So a population is just every person, animal, or thing that we want to know something about a particular context. And like I said, all of these things are best to understand, looking at them in a context. So understanding this stuff, I really encourage you, your book is really good with this, is to read the different examples and different problems in order to be able to understand this stuff. But the main goal of the introduction, I think, is to understand the difference between a categorical variable and a quantitative variable. That's something that we're going to be dealing with the whole year. And it's important when you're dealing with a situation, you have to say to yourself, wait a second, is this a categorical situation or is it a quantitative situation? A categorical variable is one that places each individual into a group or a category. Right? So in regards to people, a categorical variable would be something like, let's say, their race or their religion or their eye color or something like that, whereas a quantitative variable is one that takes a numerical value for each individual for which it makes sense to give an average. So it's basically going to, in essence, be a number that describes each individual. So in regards to people, this could be a test score, it could be their height, it could be their weight. It's something that is in essence a number. And with categorical variable, it is in essence, it is a category. So like, let's say in regards to trees, a categorical variable in regards to trees would be like the type of tree, whether it's an oak tree or an elm tree or whatever, or whether it's an evergreen tree or not, or whether it has a particular fungus or not. All right. Whereas a quantitative variable, that would be like the height of the tree or the weight of the tree or how much fruit the tree has, that sort of thing. Very typically, when you see a quantitative variable, it is going to be like a list of numbers like this. That's quantitative. In this case, it'd be the weights of a bunch of boxes, let's say, that's in pounds. And so each one of these, each box has its own little different number, its own little different weight. So that's quantitative. Whereas a categorical variable, it'll be in what we call like a two-way table like this, where these numbers are not quantitative, they're counts in categories. It's not like, and so in this case, we got a group of people, some are from Alabama, some are from Georgia, and we got their political party affiliation. Some are Republican, some are Democrat, some are other. And so we've got 46 that are from Alabama and they're Republican and so forth. So this number, it's not like one individual has this number of 46. That number is a count in a category. So it's not so much quantitative, it's categorical. Whereas this one, each individual has their own little different number. All right? But with categorical data, each number is a count in a category. So anyway, so that's the difference between quantitative and categorical variables. then we're always going to be talking about the distribution. The distribution is in essence a list of numbers. And so this would be the distribution here of the weights of the box, just every number and how often it takes that number. And so with the distribution with categorical is just in essence every category and how often it takes that. So that is what a distribution is. And in section 1, 2, and 1, 3, we're going to talk about describing a distribution in regards to a quantitative situation. So anyway, so in section 1.1, here's the main terminology in section 1.1 that I'm going to try to get you to understand by looking at the example we're fixing to do. Categorical variable we just talked about. All right, the main skill that you got to be able to do in section 1.1 is to be able to make a bar graph, whether that be a regular bar graph, a side-by-side bar graph, and a segmented bar graph, and to be able to work with a two-way table. So those are the two main skills you have to be able to do, and I'm going to show you that now. And you got to understand what a marginal distribution is, what a conditional distribution is. Marginal distribution just means add up your rows and columns. It's what that means. Conditional distribution means find the percent that are in each category, in essence, and understand what an association means. Two variables are associated when knowing the value of one variable helps predict the value of the other variable. So two variables that would be associated, for instance, would be like, let's say whether or not it rains today and whether or not I go golfing. Okay, if it rains, which it's looking like it's going to rain, and if it does rain, the probability I'm going golfing is going to go way down. Those variables are related, we would say. They're associated. All right, two variables that would not be associated would be something like whether or not it rains in Moscow, Russia today, and whether or not I go golfing. Those two things really aren't related at all. So we would say they're not associated. They don't have anything to do with each other. But so let me show you the main sort of example for today. And so let's look at this. And so by looking at this example, hopefully you'll understand those terms that I just showed you. An administrator at a school wishes to see if there's a relationship between the gender of the students and their opinion of the quality of the school lunch program. He takes a random sample, and that's going to be a really important concept later in the year. Random to us just means everybody in the population was equally likely to be chosen to be in this sample. So he gets the results below. So amongst the ones in the sample, they could either say that the school lunch program was good, it was fair, it was poor, and whether they're male and female. And so the first thing, first thing is you got to be able to identify these are categorical variables here. All right, it's categorizing good, fair, poor, and male and female. This number is a count in a category. It's not a value for an individual. It means there's 18 individuals in that category. And so the first thing it says is create the marginal distribution. So here's what the marginal distribution is. It just means add up your rows and columns. And so you would say, well, the total number that said good, you would say 18 plus 23, and that's 41. The total number that said fair, and so that'd be 16 plus 38, and that'd be 54. And then the total number that said poor would be 5 plus 46, and that's 51. Then we would say, well, what's the total number of males? So when you say 18 plus 16 plus 5, there's a total of 39 males in the survey, and then 23 plus 38 plus 46, there's a total of 107 females. And when you add those up, there was a total of 146 in the sample. So 146, and then that plus that plus that would be 146 as well. So those are your marginal distributions. That's how you find that. All right, conditional distributions, and this should say that was a different problem. This should say for male and female, because this was a different problem, but I changed it. But so for male so the conditional distribution means find the percents of each category for male and female. So what we'll do is I want to know the percent of male that said good. And so what I'll do is I'll say 18 divided by 39. And when I do that, and I'll just kind of, hopefully this will be big enough for you, 0.426. That means 42.6% of the males said good. Because it's not so much, in these situations, it's not so much the count that we're interested in, it's the percent that we want to see. We want to see if there's a difference in the males and females about their opinion. And because there's a different number of males and females in this, we really need to look at the percents. So then we'll find the percent of males that said fair. So that we'll say 16 divided by the 39. And so that would be 0.410. 0.410. So 41% of the males said fair, and then only 5 out of 39 said poor, so 5 divided by 39, and so that's 0.128, so about 13%. Now for the females, the conditional distributions would be 23 divided by 107, and so that would be 0.215, and then 38 divided by 107, so that's 0.355, and then lastly 46 divided by 107, and that's 0.430. So that's just saying 43% of the females said poor. Okay, so that's the conditional distribution for gender for male and female. Now, by the way, it could have asked, what's the conditional distribution for opinion? In other words, and you would just say 18 divided by 41, whatever that is, that would be the percent of those that said good that were male, and 18, and then 23 divided by 41 would be the percent of those that said good that are female. And so that's the other way you could do a conditional distribution. That would be, in essence, doing conditional distribution by column, and this is doing it by the rows. Okay, so conditional distribution just means find the percent that are in essence in each category. You know, and you could express it as a percent, or like here as a proportion, or in essence as a decimal. So that is the conditional distribution for male and female. Now, creating a bar graph. So what we'll do is this, is to create a bar graph, we are going to make bars going up to these percents. And so here we go. So what we'll do is all right, so we will go like this. And I will put down here, I'm going to write for each category, I'm going to say good. Our categories are good, fair, and poor. Now, my vertical axis is in essence going to be percent. It's going to be percent. And so this is opinion. This is what is known as labeling your axes. It's important to label your axes. Now, my highest percent is going to be going up to like 46% here. So I'm just going to go 10, 20, 30, 40, and then 50. That would capture all of them. So 40, 30, 20, like that. And so then I will say this, all right, so I will say, okay, the open bar that I'm going to make will be for the males, and the shaded in bar is going to be for the females. So to make a bar graph, I'm going to put bars, and so for the males, for their good, it was 46.2%. So I'll go up to about 46.2%, right like that. Okay, and then for the females, it went up to 21.5%. So, and that's about like right there. So 21.5% is about right there, and so it'd be like that. Now for the fair, for the males is 41%. So I'll go up to 41%. You know, this doesn't have to be perfect. It just needs to be reasonably neat so we can, in general, understand what's happening with the data. And so for the females, 35.5%. That's about right here, like that. And then lastly for the poor, the males was only 12.5%, and that's about like that, and the females went all the way up to 43%, which is somewhere up there, and so that is like that. And so that is what we call a side-by-side bar graph, right, like that. And so that's how you do it. But it's important to make the conditional distribution first, okay, to make percents first, because we had different sample sizes. All right, and so by making it percents, it allows us to easily compare the percent of the males that said good and fair and poor versus the percent of the females. You know, otherwise, you know, if you didn't make percents out of them, the female bar would just, it would go up, all of them would just be higher. And so, so describing this distribution is you would just describe what you're seeing, and you would say, well, so to describe this, you would say the men or the males were much more likely to say good than the females, and they're also more likely to say fair, whereas the females were much more likely to rate the school lunch program as being poor. So to describe the distribution, you just basically describe what you're seeing. And by the bar graph, hopefully makes it dramatically stand out and helps us understand what's going on here. Is that, hey, in general, the females have a they're much more likely to not like lunch, whereas the males are much more likely to like it. So that allows us to easily say that. And so to answer the question, is there an association? Yes. There's distinctly an association because of what we just said. The males are much more likely to say good. The females are much more likely to say poor. If there was no association between the variables, it means there would be no difference in the proportions of males and females in regards to how they felt. In other words, it wouldn't matter whether you pick males or females, it'd be the same. So in other words, if these bars were in essence the same height, each pair of bars, then there would be in essence no association. So in this case, there's distinctly a relationship. There's distinctly a relationship between the two variables, and there's distinctly an association. So, all right, and then I also want to show you this. I want to show you how to make a pie chart, and so that is another type of graph that can occur that you'll see sometimes. Now, the main thing, look, the main goal for this video is for you to understand the difference between a categorical variable and a quantitative variable, and to be able to do what we just did here, to make the marginal distributions conditional numbers there, and to be able to make the bar graph. That's the main thing. But also the only other way you can graph, or the only other way we really graph a categorical data is with a pie chart. Now, it's never been on the AP Stats exam to actually make a pie chart, but frequently they'll give you one, and so you have to understand what they are. And so let's say if we have this categorical data here, and so let's say if we've got this, and so this data is this, and this notation here is going to be important later in the year, but you'll see this a lot. SRS just means someone took a simple random sample. So everybody in this whole population, whatever it is, let's say that the population here was, let's say every student in a school, and we took a simple random sample. N is 162. That means there was 162 individuals in our sample, and it asked them the question, which social media app do you use the most? And so 42% said, or 42 of them, not 42%, 42 of them said Twitter, 18 said Facebook, 71 said Snapchat, 23 said Instagram, and 8 said something else. And so, and we are asked to graph this. Now, you could just make a bar graph going up to that, but what we'll do is we will make the conditional distribution. In essence, we want to know the percent. We'll make the percent. And so we would say, well, of these, 42 out of the 162, which is 25.9%, all right, said Twitter. And then we divide, so 18 divided by 162, which is 0.1 repeating, or 11.1% said Facebook, and so forth. And so 71 divided by 162, 43.8% said Snapchat, and then 23 divided by 162 is that. And so, and then lastly, 8 divided by 162 is that. And so there's our conditional distribution. And so I want to make, first of all, just to make a bar graph with one variable, so all you would do, just really quickly, is you would go like this, and you would say, okay, so here is my vertical axis is in essence percent. And so you'd say, well, the biggest percent is 44%, so similar to what we just did, 10, 20, 30, 40, 50. I'll go up to 50%. Like this, technically you just have to write down 2 numbers on the scale to get credit for scaling, but always label and scale your axes. And so then we've got, and so we've got social media app. Okay, and so we've got Twitter. So Twitter goes up to 26%, so that's like right here. And so then we've got Facebook. So Facebook goes up to 11% roughly, so that's like right there. And then we've got Snapchat. And so Snapchat goes up to 44%. So that is like that. And then Instagram is about 14%. So Instagram goes up to like 14%. It's perfectly okay to use abbreviations as long as they make sense in the context of the problem. And then lastly, other. So other just goes up to 5%. So there you go. So that is how you make just a regular bar graph. Now, to make a pie chart, this is how you would do it. And like I said, making a pie chart like this has never been on the AP Stats exam, but frequently they're given to you, and you have to be able to understand them, and we've got a homework problem or two on them. So this is what you could do to make a pie. To make a pie chart, what you're going to do is you first of all, you have to have these percents. And so you got to say, well, we're going to, so these, 25.9%, and basically 11.1%, and then 43.8%, and then 14.2%, and then lastly 4.94%. And so what we'll do is we'll start with our full circle. So our full circle here, and it doesn't have to be beautiful, but so there's my circle. That's a pretty good circle. Then what you'd realize is this. All right, half of the circle is 50%. So if you had 50%, it's just a straight line. And then if you cut those in half, by the way, that would make 25%. And so that's what I tend to do. And I graph the biggest one first. So Snapchat is 43.8%. So that is not quite 50%. So I'm just going to estimate it as best I can. So if I go like this, and 50% would be straight up, and so I go over something like this, I'm going to say, that would represent Snapchat. So Snapchat, and so that would be 43.8%. Then the next biggest one is Twitter, which is 25.9%. Now 25% of this circle would be a right angle. It would be just like that, okay? But it's just a tad more than that. So I will go just a tad more than that, like that, 25.9%. So that would be Twitter. So Twitter would be 25.9%. And now, then the smaller ones is when it gets a tad tricky. You'd realize, well, this is pretty much a right angle here. So like that would be like 12.5%, half of 25% of the circle. And so my Instagram is 14.2%, which is a little more than that. So I will go something like that. And so that would be Instagram. So that would be Instagram. And so that's like 14.2%. And then of the others we've got 11.1% in that. And so 11.1% is a little less than that. It's going to be basically double that. And I'm just going to estimate this to be somewhere around there. I mean, that looks basically double that size. And so this is Facebook. So this is Facebook. This is Facebook, and that would be 11.1%, and then lastly is the other, which is 5%. So we would say the other, which is 4.94%. And so that's a rough sketch of a pie chart. So it shows us how our sample is in essence divided up. And so that's another thing that could be thrown at you. And then a couple of other concepts are, the last thing I want to say to you is how people, first of all, how people can be deceptive with graphs. And there's a number of different ways they can do it, but I want to tell you this from the beginning. One thing is to always make sure and pay attention to your scaling. Like let's say if we had through time like this, and so here's our test scores, and so let's say this is test scores, here's our test scores, and then here's our time as time goes by in years, let's say, and through the years, and so we graph them and we go like this, and so we can very dramatically say that the test scores have gone up, but we notice that it's not scaled. And so, and let's just pretend the scaling was actually this. Well, this is 91.2, and so let's say this is 91.3. So in reality, it looks like the test scores have gone up a lot, but because of poor scaling here, they really haven't gone up hardly at all. And so a more accurate thing would be to scale it from 0 to 100. So if we did, from 0 to 100, and if we did that, then that would really better communicate what's going on. In essence, the test scores are not changing if you scale it properly. So always pay attention to your scaling. That is a big way that people can be deceptive, with graphs in regards to things. And another thing is when you make a bar graph, you have to be careful in regards to the width of your bar. The width of your bar should be the same. So let's say if we have some data here, and let's say this is the, I don't know, let's say it's the amount of oil that this company has sold. And so let's say, and it was, let's say 1 and 2, and this represents like 2,000 gallons or something, and it's gone up from 2,000 gallons to 4,000 gallons. And let's just pretend, and so this was in 2017 and this was in 2018. And so in this one it was 2,000, so it goes like that. And so, but let's say if you not only doubled, if you doubled the base as well, if you go like that, now if I make it twice as wide, now it gives the illusion that it's much more than doubled. Okay, in other words, you can't use a two-dimensional figure here. It has to have the same width, and you certainly can't make a three-dimensional figure like I tried to make in this graph. You can't use three-dimensional figures in bar graphs because it gives the illusion, even though in this situation like 1980 and 1990, it's only twice, there's only twice as much value here, but because of the three-dimensional nature of this graph, it looks a lot bigger than it actually is. So the lesson being, you can't use like a two-dimensional or a three-dimensional figure for a bar graph like this because it can be deceptive, and there's a problem that comes up like that. The last thing I'm going to say to you is this, is like I said, a big deal in regards to this introduction and section 1.1 is understanding the difference between categorical variables and quantitative variables. And there is a way. So categorical variables is in essence sort of a list of numbers. And so let's say if you had this categorical data, and so let's say if you had this categorical, or let's say if you had this quantitative data, and so let's pretend like, let's say if you had this this group of trees, and so you're measuring something quantitative, and so let's say, you know, the height of the tree, and so the height of these trees, and so let's say if you have these oak trees, and you know they have this one tree is 21.2 feet tall, another one's 27.8, another one 31.6, and another one's 39.2, and another one's 41.6, and so forth. You distinctly notice this is quantitative data, all right? But you can list any quantitative variable as in a categorical way if you put them in categories. In other words, as opposed to listing all the numbers, you could create categories. So in essence, I'll list every tree, let's say, that's between 20 and let's say 30 feet tall, and every tree that's between 30 and 40, and every tree that's between 40 and 50, like this. And then in essence you'd say, well, we have, let's say if we had 10 trees, they're between 20 and 30, and 12 trees or whatever. And so, and let's just pretend this ended up being our data set, where we counted the number of trees that were between 20 and 30 feet tall. See, even though height is a quantitative variable, because I've made intervals out of them, all right, this becomes categorical. So what this is saying is, in my sample, I had 19 trees, they're between 20 and 30 feet tall. I had 26 trees, oak trees, they're between 30 and 40 feet tall. And I had 58 oak trees, they're between 40 and 50 feet tall. So I've made a categorical variable I've made a quantitative variable into a categorical variable. So we'll be looking at examples of that. So anyway, thanks for watching the video, and we'll see you next time.